Hey guys, so in this video I'm going over the quick review that I created for Unit 1. So for the first one, I want to go to number 2, like this, because you actually had to go into a calculator and find your X and Y values so you could graph, and then once you look at your graph, then you can determine your key features. So I already did it on mine. I went in and found the two x-intercepts. I also found the vertex where it changed directions. In between 0 and -3, it was going down. In between -3 and -5, it was going down. Between 5 and -3, it actually went up. So that is why I chose -1, -5. And then I went and got 1 point above -1 and -5, and one below on the table on my graphing calculator, below the -1, -5, which was 0 and -6. So that is how I chose my X and Y values to graph. So I'm going to come to my graph those points. I have -2.60, so roughly left 2 and then 0.6. Let me change the color. And then I have -2, -3, so left 2, down 3. Then I have -1, -5, so left 1, down 5, 3, 4, 5. Then I have 0, -3, and then 0.60, so roughly about right there. And then all of these are curved because these are quadratic functions. So once we have a graph, we're asked to determine all of these key features. So the first one is vertex. Well, for a vertex, I'm going to do it in yellow. Where does the direction of the graph change? So if we follow the graph with our yellow, we're going down, 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 down. Then all of a sudden we go up. So what is the point that we change direction? Well, that point is at -1, -5. So that is the order pair, or the location that our graph changes direction. So let's erase our yellow so we can see all of the other stuff. Let's do red now. So axis of symmetry. So symmetry means cutting something in half and both sides being the same or equal. Well, if we wanted to cut this in half or fold it in half and both sides match each other, it would be this red line here. Well, to represent this line, what value is going to stay the same regardless of where we are on that line, the X value or the Y value? Easiest way to see it, if you chose a random point, let's say right here, that point would be located at -1, 1, 2, 3, 4, -1, 4. How about another point? How about right here? That point would be located at -1, -2. You could find another point. Say down here, -1, 1, 2, 3, 4, 5, 6, 7, 8, -8. What value stayed the same amongst these 3 points? The X value or the Y value? The X value. So to represent this line, we're going to say X is going to equal -1 because our X's stayed at -1 no matter where we were on the line. So let's erase our red so we can see everything else that we go through. We already did blue, let's do green. So, direction of opening. Hopefully we can see that it is opening up. Now, max or min. I'm also going to do this in green since we didn't have to write anything on the graph. Our max and min, can we pinpoint our highest point? Can we say, oh, there's a specific point that is the highest point? No, because these graphs keep going forever and ever and ever up. So there is no specific high point that we can identify. But there are no arrows going down. So we can pinpoint our lowest point, and it is that location right there, which is -1, -5. And it is a minimum, not a maximum. If we could have it pinpointed our highest point, it would have been a maximum. Now, key thing to remember with your vertex and either your min or your max is that they are always the same ordered pair. You just have to determine whether that min or that max, whether it's a min or a max. Okay. Let's erase our green. Let's do purple. So, for our y-intercepts, well, our y-axis is up here, our x-axis is there. So, where does the graph intersect the y-axis? Right there. So, at that location, it is at 0 because we did not go right or left any, and then down 3, so -3. So that is our y-intercept. For our x-intercept, we have our x-axis. We intersect here and here. Well, I purposely included these 2 points in my table. So we're looking at -2.60 and at +0.60. Then we're looking at our domain. There it goes. So our domain, always with quadratics, our domain is -infinity to +infinity. Our range is determined by our y values. So always start with the smallest. So as we go up, and if you want to, you can pull your pencil as I'm coloring up. What is our lowest point? Lowest point is found at y is 1, 2, 3, 4, 5, -5. Then we're going to keep going up. We're going to include y is -5. And then we're going to keep going. Well, there's no specific maximum point or highest point. So we're going to keep going forever and ever and include all y values that are greater than -5. So how we represent that is we're going to start with -5 because it's our smallest point and go to +infinity. Okay. And then I'm going to erase our pink. And I want our red back. So For increase and decrease, you need to bring back that axis of symmetry, which was x equals -1. So where x is -1, we have a line, a vertical line. And we want to ignore the second half of the graph for a second. We need to determine if we followed the graph with our finger, starting from left to right, are we going down or up? We're going down. So that means we are going to be decreasing. Now, what x values are involved on this side of the graph? Well, this arrow shows that we are slowly moving to the left forever and ever and ever. So we're going to reach -infinity, and we're going to keep on decreasing until we get to x is -1, because that is where our line ends, or where our axis of symmetry is going to change direction. So where x is -1, it no longer is going to be decreasing. So there's our first half of our graph. Now let's see if I can erase all of this. Nope. There it goes. So we still have that same line of x equals -1. But this time we're going to ignore the first half of the graph and only worry about the second half. So starting at that line, starting left to right, following it along with your finger, are we moving up or down? We're moving up. So if we're going up, we are increasing. So if we are increasing, we want to show what are the x values involved on this side of the graph that we are increasing with. Well, our smallest x value is found at that axis of symmetry, or that line of symmetry. So we're going to start with our smallest x value involved on this side, and then this graph is slowly going to go to the right forever, which is eventually going to reach +infinity. So that is our interval of increasing. So once we have this information, we can come in here and actually identify which one's which. So our increase was -1 to +infinity, and our decrease was -infinity to -1. So if you will, pause the video and attempt number 1. So you should have gotten the following for number 1. So for number 3 and number 4, we are told that we need to identify the transformations for 3 and 4 from the parent function y equals x squared. So honors were required to create an equation on their test, just like number 4. However, I'm going to go over it so everyone kind of understands what to do in that situation.